name is Pandya. We all are studying in Government Engineering College Bhuj in Civil Department, and here is my team.
My name is Solanki Manan. I am in 6th semester.
My name is Dr. Jignesh. I am in 6th sem civil.
Our topic is computation of the live and dead storage capacity of reservoir. Subject water resource engineering and hydrology. Guided by Professor K.B. Patel. Member Solanki Manan, Thakur Jignesh, Pandya Aryan. What is a reservoir? A reservoir is an artificial lake or pond often created by the constructing a dam across the river or stream. Reservoirs are utilized for the various purposes including water supply, irrigation, flood control, hydropower generation and recreation. What is a live storage? Live storage refers to the volume of water a reservoir that can be accessed and utilized for the various purposes under the normal operation condition. This portion of the reservoir capacity is above the level of the outlet works where the water can be released for downstream use or purpose. Live storage is essential for fulfilling the primary function of the reservoir, such as water supply, irrigation, hydropower generation. It's the active or unstable portion of the reservoir storage. What is the dead storage? Dead storage, on the other hand, it is the volume of the water in reservoir that lies between the level of the outlet works or minimum operating level. This portion of the reservoir cannot be drained or utilized under the normal operation condition. Dead storage is typically reserved for the sedimentation, debris accumulation, and as a buffer against the low flow. It essentially the inactive or unusable portion of the reservoir storage. Here we can see the diagram of the live storage and dead storage.
Method of determining a reservoir storage capacity. First, mass curve, ripples, sequent peak algorithm, flow duration curve. Mass curve method. A mass curve or a mass inflow curve is a plot of accumulated flow in a stream against time. It rises continuously as it shows accumulated flow. The slope of curve at any point indicates the rate of inflow at that particular time. Here we can see, in fact, this graph is time versus mass of mass inflow. Second method, sequent peak algorithm. Given an n-year record of stream flow at a site of proposed dam and demand, it's required to find a reservoir of minimum capacity such that design demand can always be satisfied if the flow and demands are repeated in a acyclic progression of cycles of n period each. Here we can see graph of sequential peak algorithm. It is the graph of storage requirement versus time.
The third method is flow duration curve method. The flow duration curve is a cumulative frequency curve that shows the percentage of time specified discharge were equaled or exceeded during a given period. It combines in one curve the flow characteristic of a stream throughout the range of discharge without regard the sequence of occurrence. Here is the diagram of flow duration curve. So now we will see the example on determining the dead storage of any reservoir. The question is given the lowest portion of the capacity elevation curve of a proposed irrigation reservoir. The drainage of 20 km square of catchment is represented by the following data. Here is the table given in elevation is given in meter and the capacity is given in hectare into meter. The rate of silting for the catchment has been assessed to the 300 meter square per kilometer square per year. Assuming the life of reservoir to be 15 years, compute the dead storage and the lowest sill level if the main canal is 6 km long with the bed slope of 1 in 1000 and a canal bed level at the tail end is reduced level of 594.5 meter. The FSD of the canal at the head is 80 semi. The crop water requirement is assessed as 250 hectare into meter. The first step is to calculate dead storage. It can be calculated by the rate of silting into life of reservoir. The rate of silting is given as a 300 meter cube per kilometer square per year into 20 km per year, and the life of reservoir is given as a 15 years. So we will get the 30 hectare into meter. The second step is to add 10% and into net water demand of crop water requirement. So 0.10 into 250 hectare into meter, we will get 25 hectare into meter. Now we will to calculate the dead storage level. It can be calculated by the FSL of canal at headwork. So the reduced level of a canal is given in data 594.5 meter plus 6 into 1000 plus 1 by 1000 plus 0.8. So we will get 601.4 meter. So now in the table there is a reduced level given at 600 and 602 and the capacity is 24.2 and 26.2. So at the 601.4 meter of reduced level, we have to do the difference between 600 and 602 by interpolation. So after doing the interpolation, we will get the final dead storage capacity is equal to 24.2 plus 1.4 is equal to 25.6 hectare into meter. So now we have to calculate the lowest seal level. For this, the dead storage is fixed at maximum of 3 values: 30 hectare into meter, 25 hectare into meter and 25.6 into hectare into meter. Here we are going to choose the 30 hectare into meter. So for that, the lowest seal level will be LSL into 30 hectare into meter capacity can be computed as under. So after doing this, we will get the final lowest seal level X is equal to 603.85 meter. Here we have taken example of Tapi river. The dam is constructed as earthen and masonry composite dam. The maximum height of the dam is 81 meter. Spillway gates are 22 radial gates. Total storage capacity of reservoir is 8511 into 10 raised to 6 meter cube and the useful storage capacity of the reservoir